Hi children, welcome back. Last video we have seen that characteristics of solid state. What are the properties of solid state, isn't it? Now on continuation of that, next we will see the properties of liquid state and the properties of gaseous state also. Before telling that properties of liquid state, let me say something about the solid state. That is, we have already seen that solids have a definite shape, definite volume, boundaries and all, isn't it? So, there are different properties we have seen there. Among that, we have seen that what is diffusion, isn't it? While explaining the characteristics of matter particles, we have explained that diffusion is the intermixing of particles of medium by its own, isn't it? So, here in the case of solid state, how the diffusion is taking place, that also we have to see. In solid state, diffusion takes place, but the rate of diffusion will be compared to that liquid and gaseous state, the rate of diffusion will be very, very less. A small diffusion is there in between the solid state particles. For example, if we are writing not in a smart board but on a blackboard, if the teachers are writing with the chalk, that after writing that it will be easy for us to remove after 1 hour or 2 hours. But if you are keeping that writings there for 2-3 days, after that we feel that it will be very difficult for us to clean the board. That is because that particles of chalk, that is in solid state, and the particles of board is also in the solid state. So, these two particles diffuses, that particles of chalk will be diffusing into the particles of blackboard, and the diffusion is happening there. Because of that diffusion, we feel that it will be difficult after 2-3 days, it will be difficult for us to rub the board. Okay, and we have seen that there if we can observe all these properties of solid states, we will call them as solids, isn't it? But some solids are there which shows some deviation from the normal behavior. For example, that rubber band, we can change its shape by stretching it, isn't it? But by stretching means we are applying force there, but after removing that force there, it will go back to its original shape. So, we can consider that as a solid. Okay. Then, in the case of sugar and salt, we can say that if we are taking that sugar or salt in a jar, it will take the shape of the jar. But individual crystals, if we are observing it will have a particular shape. That is what we are telling, that solids are having definite shape and boundaries and volume. It is for by considering the individual crystals of sugar or salt, not the whole. Okay. Then if you consider the sponge, sponge is also considered as a solid material, though we can compress it. If you are compressing this sponge, what will happen? You might have seen that lot of air holes there. In that all those holes, air will be trapped there. So, when we are compressing that all air will escape out, and that is why we are able to compress it. Normally, if we are trying to compress a solid there, it will be not possible for us. It is impossible for us to compress the solids. Very minute compressibility, we have seen that solids are negligibly compressible, isn't it? But in the case of sponges, though they are solid, we can compress it because of the air trapped inside that. Okay. Now, moving on to our present topic, the properties or characteristics of liquid state. Characteristics of liquid state. First of all, as just like solid state, we can see one by one what are the characteristics. The liquids do not have a definite shape, that we know. Normally liquids are taking the shape of the container in which we are taking, isn't it? Yes. So, normally liquids do not possess any shape, they are taking the shape of the container in which we are taking. So, no definite shape. Okay, then what about the boundaries? Is there any boundaries for them? They do not have a definite boundary. They do not have a definite boundary. Do not have a definite boundary. Okay, then if we consider that volume, do they possess volume? They are occupying, isn't it? They are occupying space. So, definitely they will have a definite volume. They have a definite volume. So, liquids have definite shape, no definite shape, and no definite boundaries, but they have definite volume. Then, if you consider the other characteristics, next one is they can flow from one place to another. So, they are known as fluids. Liquids are known as fluids. They can flow. They flow from one place to another. So, we can say that they are fluids. Liquids are known as fluids. Okay. And what about the intermolecular distance? If we consider that arrangement in liquid state, see, I will draw the solid state and liquid state here. These are the packing arrangement, packing of molecules or particles in solid state. After seeing that, we will identify what is the difference in the packing of. This is in the case of solids. Then now we can see the arrangement of particles in liquid state. This is the arrangement of particles in the liquid state. How do these particles are arranged? Little bit freely, isn't it? Compared to the solid state, in liquids, particles are not thickly arranged. The in between spaces are there, enough spaces are there so that they can move, isn't it? And so we can say that if we consider the next point, intermolecular distance, intermolecular or interparticular distance, intermolecular distance of space. If we consider intermolecular space, compared to the solids, the intermolecular space is more. Okay, but if you compare that with the gases, in that gas, particles are arranged like this. So, when we consider all the three states there, that intermolecular space is medium in the case of liquids. It will be more there compared to the solids, but when we consider comparing with the gas, it will be less. Okay, intermolecular space only by comparing with the solids or gaseous state we can say intermolecular space of liquids. So, if you are comparing it with the solid state, intermolecular space is more there compared to solids. More compared to solids. Okay. Then, now sixth point we can say that if we are talking about force of attraction, What will be the force of attraction between the particles in the liquid state? As they have enough space in between them, they are free to move, isn't it? So their force of attraction is less. When we comparing that force of attraction with the solid state, liquids will have less force of attraction between the particles. Okay, then what about that kinetic energy? For them, this liquid state, there is much intermolecular space in between them, so they can move from one place to another. So, kinetic energy is more compared to solids. You know, kinetic energy is the energy possessed by moving particles. So, here it is able to move because more space is there, not tightly packed there. So, they are moving, so more kinetic energy will be there than the solids. Okay. Compressibility. When we consider the compressibility, they can compressible than the solids. As the space is there, so when we compress it, that particles will come closer and closer, and liquids will be converted into solid state. At that time, we are able to compress it more than the solid state. More compressible than solids. They are more compressible than solids. Okay. So, these are the different characteristics of liquid state. And when we consider these points, one more point is what about the density of these liquids? These liquids will have a density less denser than compared to the solids. Okay. Now, one by one we can see that points once again. Characteristics of liquid state. No definite shape is there, they will take the shape of the container in which they are kept, and they do not have a definite boundaries there, and they have a definite volume, and they can flow from one place to another, so they are known as fluids. And if we consider the arrangement of particles this is the arrangement of particles in all the three different states, solids, liquids and gases. And so the intermolecular space in between that liquid particles are more compared to the solids. As the particles have more space in between them, the force of attraction will be less. As the force of attraction is less and intermolecular space is more there, they are able to move from one place to another than the solids. So, their kinetic energy is also more. And if we are trying to compress it, they all can be compressed more than the solids. And then if we consider about the densities, they have less density compared to the solids. Compared to the solids, they are less denser. Okay. Now we can see the case of diffusion there. If we consider the diffusion of liquids, we have seen the diffusion in solid state, isn't it? There the diffusion is very less, so we can say diffusion is negligible there. Okay. But in the case of this liquids, we have seen one activity there into a beaker of water, we have dropped 2-3 drops of ujala or Dettol there, and without stirring it, it intermixed each other. Diffusion of one liquid to other happened there within time, isn't it? So, these liquids are diffusing there. Diffusion rate of liquids are more there compared to the solids. Compared to solids, more diffusing, more than solids. Okay, so when we talk about the diffusion, we can talk about solid-solid diffusion and solid-liquid diffusion and liquid-liquid diffusion. Okay, so when we are talking about diffusion, we have to consider solid-solid, that we have seen, solid-solid diffusion, that blackboard and chalk, that diffusion we have seen. Then solid to a liquid diffusion, that in the case of sugar in water or salt crystals in water, they are also diffusing without stirring also they will taste sweet or salt, isn't it? So diffusion is happening there. And then liquid to liquid also, that diffusion is the liquid to liquid diffusion. We have seen the mixing of ujala with water and dropping honey to water. There also liquid diffusion is there, isn't it? Then liquid to gas. Gas to liquid we can consider now. When we talk about gases, we will see liquid to gas. Okay. Now we can see gas to liquids. So this type of diffusion, do you have any examples there to tell about this diffusion of gases in liquids? Yes, very familiar examples are there, because that water animals, water plants, they are still alive, isn't it? How do they respire? They are respiring, they are using the dissolved oxygen or carbon dioxide in that water, isn't it? That green plants, they also conduct the photosynthesis, they are carrying out the photosynthesis process, and they also breathe, isn't it? For breathing they are using this dissolved oxygen. So oxygen is a gas and that is dissolved in water. And for photosynthesis they are using the carbon dioxide gas dissolved in water. So gases also can diffuse into liquids. Okay. So this much about the characteristics of liquid state. Thank you, children.